Good afternoon, Year 5, and welcome to your Monday afternoon science lesson. Now, this week in science, we're going to be having a go at doing some experiments with things that you might have access to around your house. So for today, all you're going to need is some form of box. I'm using like a Tupperware takeaway box and some elastic bands, preferably of different lengths and thicknesses. Now, I don't have any of different thicknesses, so I'm using 4 that are of different size, and I will still get an effect. But if you've got some of different thicknesses, that's brilliant. That will make the experiment a little bit better for you. For tomorrow's science experiment, you are going to need some plastic straws. Again, if you don't have access to either of those, that's absolutely fine. You can either do the lesson later on in the week and see if you can pick some of those items up. If not, I've attached some videos to YouTube links of people doing the experiments so you can observe the experiments instead of carrying them out. So let me share my screen with you and let's have a look at our 3 starter questions. So what happens when something dissolves? What is the order of the planets from the sun? And what needs to happen for a source to emit sound? Can you have a go at answering those? If you're on Teams, then there is a Word document that you can fill in with the questions. Okay, so let's have a look. So when something dissolves, solids are mixed with liquids, and some solids will break down, so they will join the liquid, basically. What is the order of the planets from the sun? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. If you put Pluto in there as well, that's fine, but do remember that Pluto is now classified as a dwarf planet. The way I still remember this is my very easy method, just speeds up naming planets. And for a source to emit sound, something needs to vibrate. So our key vocabulary for today: a sound source is the object that sound comes from. Vibrate and vibration is when something moves continually and rapidly to and fro. Pitch is the quality of a sound referred to by whether it is high or low. Taut is when something is pulled tight, and slack is when something is not pulled tight, so when something is looser. Here are some of our working scientifically skills. Feel free to have a look through those and see if you can work out what skills we might be using today when we get to our experiment. So to start with, here is a picture of a guitar and the guitar's strings. So pause the picture. What do you notice about the strings? So have a think about that for just a second. Okay, so hopefully you will have noticed that there's a slight difference in the thickness of the strings. Over on the left-hand side, the strings are thicker than the ones on the right. And let's have a look and see what effect that has on pitch. So I'm going to show you a video. Hopefully this time it works, because last time I forgot to share the sound with you, which is quite important for this. So you can see as the thick string made a really low sound, and then as the string gets thinner, the pitch is starting to get higher. So hopefully as we go through those strings, you'll be able to see the pattern.
Because there's nothing.
Oh, we don't need the advert. So hopefully you were able to see there the different limits that the width of the string, the thickness of the string, had on the pitch of the sound. Now, if you've got different width elastic bands, then you might be able to use that in your hypothesis to have a guess at what might happen. So here's some information about pitch. So pitch means how high or low a sound is. Pitch is measured in something called hertz, and the higher the hertz, the higher the sound, the higher pitch the sound. There's a couple of interesting facts about pitch. Humans can hear a range between 20 and 20,000 hertz, but this decreases as we get older. So you guys will be able to hear higher pitches than myself and than your parents. And as you get older, that range decreases. Animals can hear a different range to humans. So dogs and bats can hear much higher sounds. If you've heard of a dog whistle, it's a whistle that if you blow into it, humans can't hear it, but dogs will start to look around because it goes at such a high frequency, such a high pitch, humans can't hear it. Elephants, interestingly, can hear much lower sounds, so they can almost feel the vibrations that come from deeper sounds than humans can hear. Pitch can be shown using sound waves. So the closer together the curves are, the higher the pitch of the sound is. This is because to make a high-pitched sound, the source needs to vibrate quicker than normal. The slower the vibration, the deeper the sound. So what you are going to be having a go at today is using a box and some elastic bands to investigate how we can make high-pitched sounds and how we can make low-pitched sounds. Like I said, if you've got thick and thin elastic bands, that's brilliant for this experiment. If not, you can just use elastic bands that are different sizes, just like these ones are. So what I'd like you to do is I'd like you for this experiment to have a go at completing the method that I've saved into Teams. Give me a hypothesis. Now, that depends on whether you've got different thicknesses. So you can either say, I think that the thick elastic bands will create a lower pitch, or that the tight elastic bands will create a higher pitch or a lower pitch. It's up to you, depending on the resources that you've got around the house. Then you can do the findings. You can have a go at doing it. Even if you don't have a box, you can just hold the elastic bands like this and it will make a sound. And then how would you change it next time? Obviously, it's a little bit of a tricky situation because of it doing it at home. Let me show you what you have to do. So with your box, you need to put an elastic band around it, and then I don't know how well you'll be able to hear it, but once it's round like this and I almost pluck it, you might, if I put the microphone next to it, you might be able to hear a sound. And then if I put a different sized elastic band around, so this one's the smaller one, and if I put it around the same side of the box, then hopefully when I pluck the elastic bands, I should hear two different pitches. So let's see. So hopefully you were able to hear that I had two really different pitches there. So the tighter elastic band made a higher pitch. Now, if I wanted to make it tighter still, I could put it around my Tupperware box the other direction. And again, hopefully you guys can hear something when I pluck the elastic bands. You'll hear a slight difference in pitch. Now, I will put in a video in the YouTube link as well, because there is a way that you can change it. So if you pull it tighter like this, then you can get different sounds as well. But have a go at carrying out the experiment and seeing what you find. How can you make the sound, the pitch higher or lower? Good luck with it. Hopefully you guys will have enough things at home to be able to have a go at it. If not, watch the video to get a bit of an understanding of how you can alter the pitch when you're playing a string instrument.